So 9/10 number 3, we want to find the Taylor series for f of x equals cosine x centered at the point c equal pi over 4. So the Taylor series will be a series of the form summation n goes from 0 to infinity, a sub n, x minus pi over 4 to the n, where a sub n is the nth derivative of the function evaluated at pi over 4 divided by n factorial. Right? So that's the definition of the Taylor series. And for f of x equal cosine x, it's easy to find the derivatives because they repeat every 4 times. So f is the cosine. The first derivative is minus the sine. The second derivative is minus the cosine. The third derivative is plus the sine. And the fourth derivative brings us back to the cosine. So then it just repeats. And we have to know what is the value of the function at pi over 4. So f of pi over 4 is the cosine of pi over 4. That's 1 over root 2. Minus the sine at pi over 4 is minus 1 over root 2. Minus the cosine at pi over 4 is minus 1 over root 2. The third derivative at pi over 4 is 1 over root 2. And the fourth derivative brings us back to 1 over root 2. So these are the values of what's in the numerator there. So, so what we have is that, what is an equal to? Well, it depends on whether n is a multiple of, see these numbers go 1 over root 2, they're all 1 over plus or minus 1 over root 2. It's minus, it's plus, minus, minus, plus. So this is equal to 1 over the square root of 2 times n factorial if n is 0. So if n is a multiple of 4, let me write it here where I have more space. So if n is equal to 0, 4, 8, 16, and so forth, you get 1 over square root of 2 times n factorial. And similarly, if n is 3 or 7 or 11 or 15, 3, 7, 11, 15, and so forth. So these are the numbers that when you divide them by 4, leave a remainder of 0, and these leave a remainder of 3. And for the other numbers, it's minus 1 over square root of 2 n factorial. So that is 1, 5, 9, and so on, or 2, 6, 10, and so on. So those are the numbers that go into the power series. So the book gives a kind of a somewhat more complicated way to describe this. So this is always going to be plus or minus 1 over the square root of 2 times n factorial, or some people prefer to write that as root 2 over 2 times n factorial. And you have a plus or minus 1, minus 1. To what power? Well, it's something which has to be even if n is one of these numbers and odd if one of these numbers. And for whatever curious reason, the book chooses to write this as n times n plus 1 over 2.
And then x minus pi.
Which is always 1. So the book is actually wrong.
So we don't have to do that whole.
Sorry, actually, no, let me be a little bit more careful about that. So if n is divisible by 4, this is even. If n plus 1 is divisible by 4, which puts you in this case, this is even. If n is one of these numbers, this is odd. So this expression is a correct way to like get the plus or minus sign correct here. But you can either write it like this or write it like this. It's really your choice. If you write it like this, then you get the following Taylor series. F of x, or cosine x, is root 2 over 2, because that's in every term. Summation n goes from 0 to infinity. You can have an n factorial and an x minus pi over 4 to the n, and this is going to be minus 1 to the n plus 1 over 2. So that's the form in which the book gives the answer, because you can write it as a concise expression, but anything like this is just as good.
Okay. Thanks.
Professor,
Yeah,
can you do the sample final?
okay.
Thank you.
Which problems?
Number 9.
So this is sample final number 9. Goes as follows. So you have a patient who's being prescribed 300 milligrams of painkiller a day at 11 a.m. And 1 day later, 20% is left, 80% is excreted. So what amounts of painkiller are in the patient's body measured at 10:59 a.m. immediately before that day's dose is given, after 1 day and after 2 days of treatment? So here's what happens. On day 0, you administer 300 milligrams. Only 20% is left the next day. So after you give the 300 milligrams the next day, so at day 1, at 10:59 a.m., the amount left in the patient's body is 1/5 of 300, which is 60 milligrams. So after 1 day, that's how much the patient has. What about day 2 at 10:59 a.m.? Well, every day you lose 20%, you lose 80%. So only 20% is left. So of the 60 milligrams on day 1, 20% of that, or 12 milligrams, is left on day 2. Meanwhile, on day 1 at 11, you give the patient another 300 milligrams. From that second dose, 60 is left. So on day 2, the total amount left in the patient is 72 milligrams. So after day 1, 60 milligrams. After day 2, or on day 2, 72 milligrams. So is there a question how I got that part of it? Okay, now,
No, thank you.
but the hard part is part B. Use a geometric series to compute the amount of painkiller in the body after a very long time of treatment. That means after, let's say, n days have gone by. So what is this 72? This 72 is 60 plus 1/5 of 60. That's how we got this. What would happen on day 3? Just to get an idea about how to do part B. On day 3, we would have 1/5 of this amount. So that's 1/5 of 1/5 of 60. That's 1/5 squared. We would get 1/5 of this 60. And then we would get the 60 left that we got from, you give 300 milligrams at 11, another 60 of that is left on day 3. So on this day, you have 60 plus 1/5 of 60, or 60 times 1/5, plus 60 times 1/5 squared. And in general, on the nth day, the amount you will have is 60 plus 60 times 1/5 plus 60 times 1/5 squared. You have this geometric progression with a total of n terms. So the last term is 1/5 to the n minus 1. And if you add that up, what that's equal to is 60. I mean, this is the formula for geometric progression, 1 minus 1/5 to the n over 1 minus 1/5, which is 60 times 1 minus 1/5 to the n over 4/5. 60 over 4/5 is 75 times 1 minus 1/5 to the n. So after n days, this is the amount of medicine that will be inside the patient's body. Any questions about that?
No.
No, thank you.
Okay. Anything else I can do?
So, based on the sample exam, should we practice more Taylor series? Is that going to be like the majority of the exam?
Well, on this exam, it was one question. No, sorry. Uh, 3 questions.
Yeah.
Well, that's reasonable.
Okay.
So, I mean, in the course, so look at the exam. The exam has 15 questions.
Yeah.
So maybe half the course was integration,
Yeah.
and then a quarter was infinite series and power series, Taylor series, and then some differential equations. So that's about the proportions on this exam. And that's, I guess, what the proportions on the final would be like.
Okay. Yeah, I'm just a bit nervous.
Mhm. Well, I mean,
Yeah.
we cover a huge amount of material in a very short time. I mean, we
Yeah.
covered the syllabus, but we have to cover the syllabus in 3.5 weeks instead of 14 weeks.
Yeah. Kind of liked it better this way because information just kind of sticks to you.
Yeah, but you don't get much time to practice, let it sink in, develop skill with the techniques.
Yeah, it's more
I mean, that's my point of view. It's
a bit more rushed.
anything else?
No. No, I don't think so.
Okay, well, if there are no more questions, we will quit. And I'll go back to making up exams.
All right, thanks. Thanks for
All
everything.
right. So the exam will be posted and emailed to everybody a little bit before 3 o'clock, and just like the previous midterm.
All right.
All right. Bye, everybody.
Thank you.